So here we are, Math 2303, differential equations. This is workshop 10. And I've got some solutions. I've gone ahead and done some things here, but I'm going to explain things as we go along. The formula, here it is, for a periodic function is, and just a little, it's in the bracket there, is given by given right there. You're integrating, capital T, by the way, is the period. In this case, it's 3. Capital T, you see that it's every 3 times, every 3 values, it repeats itself. For the first, from 0 to 2, the function is 1. From 2 to 3, it is 0. And then it repeats itself. T equals 3, period equals 3. That's capital T in the formula. So you need to integrate the formula from 0 to 3, from 0 to capital T, I should say, capital T there, 0 to capital T, e to the minus st, f of t dt. And so noticing that the function is 0 from 2 to 3, I've put it in there, but we're going to get 0 for that. So the only part of this integral that matters is from 0 to 2, and it is this. It's 1 times, I'll put the 1 in. It is 1 times e to the minus st. We integrate that with respect to t, and here's the antiderivative. Putting the upper and the lower limits gives us the appropriate things, and we can then simplify it to make it look like that. If you get to this stage right here, you've pretty much solved the problem. I've just cleaned it up a little bit right here. So that's periodic function. What's involved with that one is that formula. That formula right there, you need to know for the final exam. Okay, so now we move along and look at the Laplace transform of the convolution of 2 functions. Here, I've written down the convolution of the function f and g. Here's one version of it. Or I can interchange the t minus v and the v with the functions, and there it's all the same. Sometimes this is the better one to use, sometimes this is the one. And so here's our first problem, and here's the result of that. The Laplace transform of the convolution is very easy. This is an easy problem. You just do each one separately and write them down. So you will see that, for instance, for t to the 5th, I've got 5 factorial over s to the 6th. And for cos of t, s over s squared plus 1. Simplifying, the s's, 1s cancels, and we end up with this. So for this problem, you have to recognize that this is the convolution of 2 functions, because here I have e to the t minus v, sine of v. So it's this form right here. It's the convolution of 2 functions. And the convolution of e to the t is 1 over s minus 1. The Laplace transform of e to the t, 1 over s minus 1. Laplace transform of sine, 1 over s squared plus 1. So here's a matter of recognizing that we actually have the convolution of 2 functions. This is an easy problem when you remember that. You need to remember that. So now we're going to move down, and I'm going to do the next one, which is we're going to find the inverse Laplace transform. So now here, this is the more complicated direction. Doing the inverse Laplace transform involving a convolution requires sometimes a little tricky interval. And so here we have this. So we have f of s. So we have f of s is going to be the convolution of h and t. And now I've said that h of s is the 1 over s. G of s is 1 over s minus 5. I've picked those conveniently so that that works nicely. And so now we have the inverse Laplace transform of this is h of t, that's 1. The inverse Laplace transform of g, capital G of s, is e to the 5t. So now we have to decide, how do I want to put this in? And I would let h be the 1 here. So I will then have a 1 here. And the g of v is e to the 5v right there, e to the 5v. And now I do that antiderivative with respect to v, remember, from 0 to t. And we end up with this. Just to mention one thing here, if I was given this problem and I looked at this, I think I would attempt to do this by partial fractions. And if that was the case, I would be finding something over s and something over s minus 5. And I'm doing the partial fractions of that when this would be minus 1/5. And when s is equal to 5, this would be 1/5. And so when I do the inverse Laplace transform of that, I get minus 1/5 plus 1/5 e to the 5t. You see, we got the same thing. I got there a little bit faster. If you have your choice, I would do a partial fractions and then you have it broken down. Anytime you're doing a convolution, it's a kind of a messy calculation. So I'll stop this side of the page and end this now, and then we'll have a new one for the other side.